Anyway, all right.
Everything's cool when you're part of a team.
All right.
Because everything is awesome.
Okay, all right, sorry. Antiderivatives 4.8, calculus 2, and differential equations. So, all right, so antiderivative, what do you think that should be? It's the opposite of derivative, right? Okay, so just like multiplication has an opposite, which would be?
Division.
Division. Addition.
Subtraction.
Okay.
Square.
A power.
Square. The root.
A root. See? Got you there. Okay.
Get me there.
So if I say a square, you would say square root, right?
Yeah.
But it'd be power versus a root. Okay. Everything has a opposite function for it. So for all these derivatives that we're doing, we can work backwards to find what we have.
What about factorial?
Factorial?
Yeah.
Factorial's like there's really not for that, because factorial is just like, if it was 9 factorial, it'd be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is 9 factorial, but it's just a way of multiplying.
But there's no expression to like get you back to the base number?
And upside down.
Good point. We'll try that in the Taylor series. Okay. All right. Anyway. All right. So let's take a look. Antiderivative. So, bam. Okay. So we denote this with the capital F, and then we go from there. Okay. Yeah. So anyway, all right. Here, F antiderivative. Okay. F plus C. C is an arbitrary constant. Do not forget the C whenever you take the derivative. So find the antiderivative of this. So now from right here, this would be F equals
C.
Yeah, or I'm sorry, F of X, sorry. So capital F of X equals C, right?
Yeah.
So some constant. So when I took the derivative of some number, it came out, okay, it came out to be 0, right? Okay, so now, wheel of truth. Let's take a look. So if my derivatives for my trig,
This is what I do.
sine, cosine, negative cosine, right? So if a derivative goes this way, a integrand. Oh my
man.
Anyway, so let's. All right, so this thing
It's Tuesday.
it's Tuesday, my dude. All right. All right, so integrands actually go the other way. So derivatives goes clockwise, antiderivatives go counterclockwise. All right, so if I'm going in that direction, so this would be G of theta would be
Cosine. Theta
cosine theta
plus C.
plus C. Thank you. Yeah, pretty basic, right? Está muy fácil. See? All right. Okay, so same thing goes for this. So with the power, so if I were to take the derivative of that, okay, if I were to take the derivative of that, what would I have done? Multiply out the front
And then subtract that.
and subtract for the top. Okay, so now what would be the opposite? Okay,
You add one. And then
add one to the top and then
divide.
divide by it. Add one to the top and divide by it. Because that's going to be the opposite of what we're doing, right?
Yeah.
Because derivative, we're going to multiply it out front and then subtract 1. But now we're going to add 1 and then divide by it. So if I'm adding 1, so it's going to be h of x is equal to, so let's go ahead and add 1. So it's going to be
3 halves.
x to the 3 halves over 3 halves, right? I don't like dividing fractions. I always multiply by the reciprocal. So I'm going to flip that bad boy over. So it's going to be, so 2/3 x to the 3 halves.
Plus C.
plus C.
Oh,
Yeah.
why you keep forgetting?
Hey, he's gonna be the first one to forget that one.
I know, right?
I am.
You know what's so funny? I gave a quiz over this stuff last year, and a lot of people, that was the first thing they did on the quiz, wrote plus C on everything. On every single one, that was just plus C. I was like, really? Do you remember that one?
Wasn't it just Jonathan who forgot it?
Yeah, and he still forgot it. All right, so look, here's a whole bunch of it. Yeah. I know. Look, you got so right here.
There's an F on that one.
Yeah, there is. Yeah, there is an F of plus a C. Be like, no, Mom. Yeah, it's all calculus. It's F of X plus C. So it's a function, not my grade. All right. Anyway. All right. There. F that. F that.
Yes.
Okay. F that. Hola. How are we doing? Thank you very much. All right, antiderivative of this. All right, guess what? F that. All right, general solution, function equation. So, okay, solve differential. So now listen up. So this is the one I wanted to get to. So the boundary of condition, the initial condition is used in conjunction with the general solution to find the particular solution to a differential. Now, put in basic. We're solving for C. We're going to solve for C. That's what we're doing. To find a differential equation, you do the antiderivative with an x and a y, and then you solve for C. Okay, so, hey look, there's my derivative. Okay, so therefore, y, so if I have a dy dx, that means that was the derivative of the function y, right?
Yeah.
Of the function y in terms of x. So therefore, it would be y equals, remember, add 1, divide, right?
Yeah.
So it's going to be x cubed
1/3.
over 3, right?
Yes.
And then it's going to be plus 2x squared over 2. I'm not simplifying anything
Okay,
yet.
yeah.
I'm not simplifying. I don't want to screw up anyone. All right, and so then it's going to be plus
X
x
over 1.
to the 1, right? Over 1, right? Okay,
Go ahead,
over
right.
1. Okay.
Put the 1 in front
So,
of that.
oh yeah, you want the 1 there too? Okay, good. All right. Now, and what is that guy never going to forget?
Plus C.
He did this time.
There we go.
because he didn't say anything.
I was laughing, I swear.
All right, so we're good. So now we're going to try and solve for my initial condition. So with the boundary condition when x is 3 and y is -1, verify the solution. So that means we're going to plug in
X or Y.
x and y. Let's do that. So it should be -1 is equal to, that's going to be x, so it's going to be, let me see, 3 to the 3rd over 3 plus 2 times 3 squared over 2 plus 3 to the 1st over 1 plus c, right? Now, a lot of times they'll put in like a c sub 1 or something like that because you quite possibly could have more than one solution. So if I'm starting from the, let's say we're starting from the acceleration. If I'm starting from the acceleration, so this one right here, if I'm doing, motion on this one, this would be my velocity, wouldn't it?
Yeah.
Okay, so if I was doing from the acceleration, that's a second derivative, right? So that would be the second derivative. So when I take my first antiderivative, that would give me to the velocity, right? That would give me my velocity, so I'd have like a c sub 1. But then when I did it again, right, to go from velocity to position,
Yeah.
I'm going to have another c, right?
Yeah.
So that would be a c sub 2. So I'm going to have two values there that I'm going to have to try and solve for from some type of initial values. Okay? So like I would have an initial velocity and I would have like an initial position to be able to go through and find these things. So on this one right here, let's go ahead, plug in. So it's going to be, what's that? 27 over 3 is 9, -1. That's going to be plus 9 plus 3 plus c. So that's going to be 18, 19, 21, 21. Subtract, that's
20 equals C.
negative 22
2, I mean.
equals c.
That's the weirdest.
Yeah? Yes?
Yes.
No?
Yep.
Yeah.
Okay. No, don't forget, it's, yeah. So, you guys are double checking my work. Sometimes I'll just screw up on some math just to see if you're paying attention.
Facts.
Just so you know.
That's what
Okay.
that's what a real teacher does.
I know, right?
I like
So
it.
if you're not paying attention, then you're like, bruh. See, but you won't say it like that. You'll say it a little bit more. You're like, all right. Bruh. All right. Are we okay?
Yeah.
So my solution, so my whole thing right here should be y equals x cubed over 3 plus x squared plus x minus 22. There we go. That's what I got for my initial condition. Yeah? Okay. All right, so differential equations often involve higher order derivatives. For example, the equation, that's second derivative, is equal to that. This is an example of second order differential equation. The order of a differential equation is the order of the highest order derivative of y appearing in the equation.
He said order 3
Order
times.
3 times.
Did I
Order
did?
of differential equation is the order of the highest order derivative.
Order.
Hey, you say it twice on the one time.
Yeah, okay, all right.
Yeah, there's a lot of orders.
I guess I'm pretty adamant about order. So make sure you keep it in order. All right. So I guess I'm here to take an order. All right, yeah. All right, solve differential equation. Okay, with the boundary conditions x equals 0, then y equals 1, and when x equals 3, then y equals 8. So we're gonna go through and set it up. So I think this one right here has a typo on it, because I think it's supposed to be, you know, my first condition and second condition. So I gotta double check this. I will. Anyway, let's go through and actually do what I'm supposed to do anyway. All right, so now if I'm starting with the second derivative, my first derivative, so my dy dx should be 12x cubed over
3.
plus c, and I'm going to call that one c1 because I feel like it. Why not? Yes? Hey, that guy.
Yep.
Yeah?
Yeah.
Okay, good.
She's a
All right.
yes.
Yes. All right.
Yes.
Okay, so next one, J.
Yeah.
All right. So next one. So the next one after that would be a y equals, right? So y equals, so I'm moving up the ladder on this one. So that would be, so if I reduce that, that would be 4 anyway, right?
Yeah.
So it would be 4x to the
To the 4th.
over
4.
plus c
Sub 1.
1.
Plus C sub 2.
Ah,
Ah.
that's some value, right?
Yeah.
That-
So X.
X, thank you. X. Do you really want me to write to the first?
No, you're good.
Okay, I'm good.
I mean, you did
I'll let it
sub
slide.
1.
But sub 1 is important.
Yeah, it is.
That is important. Okay, so now since this is some type of number here, right?
So now you're gonna have substitute there.
So that is some type of number there, right? Because there's that, and then now
Sub 2.
sub 2,
Yes, sir.
c sub 2. Because I would have an initial, so if I'm talking about like the position type thing, velocity, acceleration, all that other good stuff.
Good to
So
keep tabs.
this right here, the c sub 1 would be my initial velocity. My initial velocity. So when I plug it in, I would have an initial velocity of this. Then I would talk about my initial position for my c sub 2. Does that make sense?
Yeah, no, it does.
Okay.
I get it.
Like I said, I think when writing this up, there's a typo on that. So I just want to double check. So, because I think it was supposed to have 2. So it said from one to the other.
X equals 0 to 1, and 3 to 1.
Okay. Yeah. So yeah, I was right. It's kind of a typo here. So on here it says my initial condition. So with the boundary condition, so x equals 0 and y equals 1 is going to go for my C1. So this goes with my C1, and this goes, and the other one goes with my C2. So when x is 0, okay, let's take a look. So x equals 0. So now right here, all this right here in the function, my dy dx, remember this represents, so in my motion, this would be the velocity here. So that means my velocity would equal to 1 there. So this would be 1. So I'd have 1 equals, now if x is 0, this becomes 0 plus c1. So c1 equals 1. Okay, that's going to be helpful here, right?
Yeah.
Okay, good. Now on the next one, so watch, I'm going to reduce that. Bam! Oh, make me so much better. All right, so the next one is going to be, the y is 8. So now I'm going to have 8 equals, now my x value is going to be 3, right?
Yeah.
Say yes.
Yes.
3 to the 4th plus,
Just x. 'Cause
yeah, just x, because my c1 is going to be 1, right?
Yep.
Plus x, which is 3, and plus c2, right? So 3 to the 4th is going to be what?
Sub 2, not to the 2.
Oh, yeah, sorry.
Yeah.
Oh, man. So c2.
Thanks, Einstein.
3 to 4 should be 81, right? 81 plus 3, 84. Subtract 84 from both sides.
Go ahead.
76?
You're nine.
Yes.
Yeah.
76? Okay. So I get 76
If I answer everything.
Negative.
equals c sub 2.
Negative.
Negative. Okay, so. All right, so where are we at now? So can I actually write out my equation now?
Yes.
Yeah. All right, so it should be y equals
X to the 4th
x to the 4th
plus x
plus x
minus 76.
minus 76. Bam.
Our starting position.
Okay.
Okay, Newton.
Okay. Just making sure. All right, so. All right, we happy with that? Or no? We're not happy with that.
I'm pretty happy.
Okay.
Let's skip the reruns.
Brings back memories.
Okay. All right.
Like and subscribe.
All right. Hold on. Oh, yep. Guess what? Like and subscribe.